minimum thickness of sealing compound in an explosion-proof fitting is 0.5 inches. This requirement is found in the National Electrical Code, specifically Article 501, which covers Class A locations. Section 501.25c pertains to explosion-proof enclosures. The purpose of sealing fittings in explosion-proof systems is to prevent the passage of flames or explosions from one part of the electrical system to another, and to limit the passage of gases, vapors, or dust at atmospheric pressure. The proper installation of sealing fittings is crucial in hazardous locations to maintain the integrity of the explosion-proof protection. Several factors influence the selection and installation of sealing fittings, including the type of hazardous material present, the ambient temperature, and the specific requirements of the electrical equipment being used. Sealing fittings are typically installed in conduit runs near enclosures that house arcing, sparking, or high-temperature devices. They are also used where conduit enters or leaves a hazardous location. The type of sealing compound used must be compatible with the hazardous materials present and must be capable of withstanding the temperatures and pressures that may be encountered during an explosion. The installation process involves several key steps. Firstly, selecting the appropriate sealing fitting for the conduit size and type. Secondly, ensuring that the fitting is properly cleaned and prepared for the sealing compound. Thirdly, mixing the sealing compound according to the manufacturer's instructions. Fourthly, pouring the sealing compound into the fitting, making sure to completely fill the void around the conductors. Fifthly, allowing the sealing compound to cure properly before energizing the circuit. It is essential to follow the manufacturer's instructions carefully to ensure a proper seal. Improper installation can compromise the explosion-proof protection and create a significant safety hazard. Regular inspection and maintenance of sealing fittings are also important. Over time, the sealing compound can degrade due to exposure to chemicals, temperature changes, or physical damage. If any cracks, gaps, or other signs of deterioration are observed, the sealing fitting should be replaced immediately. Furthermore, when making any modifications or repairs to an explosion-proof electrical system, it is critical to reseal any fittings that have been disturbed. This ensures that the system continues to provide the required level of protection. The NEC provides detailed guidance on the installation and maintenance of explosion-proof electrical systems, and it is important to consult the code for specific requirements. In addition to the minimum thickness requirement, the NEC also specifies the types of sealing compounds that are permitted for use in different hazardous locations. The code also addresses the spacing requirements for sealing fittings, as well as the procedures for inspecting and testing sealing fittings. Compliance with these requirements is essential to ensure the safety of personnel and property in hazardous locations. Explosion-proof equipment is designed to contain an internal explosion and prevent it from propagating to the surrounding environment. This is achieved through the use of robust enclosures, threaded joints, and sealing fittings. The enclosures are typically made of heavy cast metal and are designed to withstand high pressures. The threaded joints are designed to provide a tight seal that prevents the escape of flames or hot gases. The sealing fittings are used to seal the conduit runs and prevent the passage of flames or explosions through the conduit. The proper selection and installation of explosion-proof equipment is critical to the safety of hazardous locations. It is important to consult with qualified professionals and to follow the requirements of the NEC to ensure that the equipment is properly installed and maintained. Furthermore, it's worth noting that different types of hazardous locations exist, each with its own specific requirements. Class I locations, as mentioned in the NEC article, are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. These locations are further subdivided into divisions based on the likelihood of the presence of the hazardous material. Division 1 locations are those where the hazardous material is present continuously, intermittently, or periodically under normal operating conditions. Division 2 locations are those where the hazardous material is present only under abnormal conditions, such as a spill or equipment failure. Each division has its own specific requirements for explosion-proof equipment and wiring methods. When working in Class I locations, it is essential to understand the specific requirements for the division in which the work is being performed. This includes selecting the appropriate explosion-proof equipment, installing it properly, and maintaining it in accordance with the manufacturer's instructions and the NEC. In addition to the NEC, other standards and regulations may apply to explosion-proof electrical systems. These may include standards from organizations such as the International Electrotechnical Commission and local or regional regulations. It is important to be familiar with all applicable standards and regulations before working on explosion-proof electrical systems. The use of properly installed and maintained sealing fittings in explosion-proof electrical systems is a critical safety measure in hazardous locations. It helps to prevent explosions and fires, protecting personnel and property from harm. Always adhere to the NEC and other applicable standards and regulations to ensure the safety of these systems. Remember that electrical work in hazardous locations should only be performed by qualified and experienced professionals who have a thorough understanding of the applicable codes and standards.